Okay, I guess we can start. It's 20 to noon now. I'm Gojko, and today I'd like to talk to you about a couple of really interesting trends that started kind of emerging last year or a year and a half that I think will have a significant impact on how we deploy apps in the future. I know this is a .NET related conference, but most of what I'm going to be talking about relates directly to the Amazon cloud. I think I don't really do a lot of work on the Microsoft cloud, so I don't know the equivalent features, but given that Microsoft is a reasonably fast follower, I would expect most of these things to be available on the Microsoft cloud as well at some point. I kind of started building a new product about 6 months ago because I'm building it on my own and I'm doing lots of other things at the same time. I really needed to reuse as much as possible what other people have done and services that were in the cloud available to me. And a nice thing about starting something from scratch is that you can actually get a clean slate and do a bit of research and figure out what's available now that wasn't there a year ago or a year and a half ago. And I was quite surprised how far I got just by linking together things that were already provided. And that's kind of part of what I want to talk about. I think I probably saved a couple of months of my work just by doing kind of research and figuring out what's available there, partially because of kind of these new trends that are emerging I want to talk about. So one of the kind of first things that is interesting to look at is how the cloud services are evolving over time and where this is going. I think we are kind of so far over the last, 20 years, we're kind of going through 4 different stages of cloud deployments. Most people, when they think about cloud software, they think about kind of virtual machines or even higher level abstractions that are done now. But I was an editor of a magazine somewhere 2001, 2002, when I remember reading an article from somebody who submitted it about Hewlett-Packard doing something that was incredibly innovative in 2001, how they're going to reinvent computing by basically providing utility computing. It's like almost like you're getting water or electricity computing on tap. That was 2001, so it's, not AWS or Azure or something like that. And, like in many other things, people who had the concept first didn't really get to monetize it that well. But what they were talking about is how effectively, we will have these big organizations that are really good at operating infrastructure, and people will just kind of pay for the convenience of using that infrastructure then. And it took us a bit of time for software to start emerging there. And I think, the first really cloud stuff, I remember when people talking about cloud in 2003 or 2004, that was Salesforce. And things like Google Analytics, that was amazing because you don't have to install an app. You don't have to operate an app. You just pay for the convenience of using it. So kind of the first stage of cloud really was paying for the convenience to use business applications. CRMs, kind of analytics packages and things like that. And the thing that they were actually selling was the convenient access to applications where, they will operate the infrastructure, they're going to patch the boxes, you don't have to care about that. Now, somewhere in 2007 or 2006, Amazon kind of realized Amazon is really, really good at mining metadata. They realized that people like kind of paying for convenience of this stuff. In 2007, I was working as a contract developer for one of the biggest telcos in England, telecoms providers, and it took them 9 months to set up a virtual machine. So So the code was done, it was tested, it was ready to go live, 9 months to get the virtual machine allocated. With all the bureaucracy they were doing. And for me, playing around on Amazon in 2007, later with a startup was amazing because we can get a virtual machine set up in about 30 minutes. Even kind of, if you're not doing something crazy, 20 minutes. Hey! And kind of we started getting this infrastructure level as a service where they realized, okay, there's a limited number of these business components, but if we sell people convenient access to hardware abstractions, that's amazing. But we were still kind of doing it on a subscription basis. The pricing was a subscription model. You were paying for a machine for a month or something like that. And a bunch of other services emerged like Heroku or Google App Engine and things like that, where they're kind of trying to create slightly higher level abstractions. But then again, Amazon being Amazon, they're really good at mining metadata. They figured that people want to run databases and queues and things like that on those machines. You don't necessarily want a machine. No, nobody, okay, not nobody, but you have to have a serious personality disorder to enjoy patching security on a Linux box and chasing kind of file systems around and things like that. And the reason you can start to sell the convenience of basically utility components. And this is where we got the rise of databases, queues, and they're still doing that. A month or so ago, Amazon realized that what people would really like to do is run Mongo databases on their machines, but Mongo is difficult to administer on that scale, so they kind of rewrote their own and launched it. So we're going to see more and more of this stuff. But what's really interesting here is that the pricing, about 2 years ago, started to switch from subscription-based stuff to utilization-based stuff, where there was this whole emergence of services like Lambda or Azure Functions or Google Cloud Functions, where you're paying for code at increments of 100 milliseconds in the processor. So we're no longer looking at reserved capacity. We're no longer planning virtual machines. We're no longer planning databases capacity. Amazon recently started selling database access to kind of MySQL and Postgres and things like that at request pricing. So that means that if I need 50,000 requests this hour, but 5,000 requests next hour, and 5 million requests the hour after, they're going to scale up and down the infrastructure dynamically because they're so good at doing that. I don't have to care about that. All I have to do is pay per request. So, and what is happening, I think, and started happening about a year and a half ago that I think is really, really interesting is getting to yet another stage. It's kind of closing the circle to where we started. We started with convenient access to business applications, then went through hardware, utility components, and we're getting into kind of the next stage of cloud that I think is I don't know what a good acronym is, but maybe something like this, that's kind of business components and deployment as a service, where we're no longer, what I'm seeing is kind of cloud providers getting into the higher levels of delivery where they're mining this stuff. So they're realizing that, okay, now we have databases and queues and stuff like that, we can offer business components that are kind of as a service. So wiring up business components in the cloud is, of course, nothing new. From day one, Salesforce was selling the cloud on a business component level, but they were selling entire applications. And then later, kind of, third parties or smaller organizations like Zapier realized that lots of companies really want to link Twitter to Slack, and they want to link their database to email, and they want to link all these things and just wire them together. But and kind of, you can do this with Zapier, you can do this with if this, then that, and things like that, but they're all kind of trying to link things through multiple different providers, multiple different offerings, where it's really, really messy because you don't control the availability of any of that. Everything talks with a different protocol. Different things have different capacity. You can do, and kind of, what I think is happening right now as a trend is cloud providers are basically getting in on this. They've realized that lots of small companies are starting to kind of fill this niche, and big companies need this. So Amazon is basically starting to play this game. And I'd expect Microsoft to start playing this game very soon, where you can get most of these business components from them, and you don't have to worry about wiring something that's in this part of the world to this part of the world. You can kind of deploy stuff in your region. You can reuse it. One of the kind of really interesting things that emerged relatively recently on Amazon is this application called Pinpoint. Pinpoint is somewhere between a CRM and an analytics package and a contact package and a messaging package. So it's kind of lots of these business thingies inside it. And on a very, very basic level, you can think about it as kind of Google Analytics hosted in Amazon. But unlike Google Analytics, where you can't really program it, you can just send events to it, Pinpoint you can program. What I mean by that is you control the session key, for example. So it's trivial easy to correlate front-end, back-end, and back-end events and queue events and 2 months later events with the same session, because you control the whole thing. It's very easy to export events out of Pinpoint because they are your events. With Google Analytics, you're using a Google Analytics service. They don't want to give you the events. They want to keep you there. Where with this, you control the storage. So you can parse events, change events. You can replay them. You can do all sorts of really, really interesting things here. It's a programmable analytics component. And what they've added to it 6 months ago is they've added marketing campaigns to it. So now all of a sudden you can do all kind of crazy marketing stuff, like find all the users that had this event in the last 3 months, send them this templated email. Or you can even do transactional emails through it. So kind of we're getting more and more higher level stuff. They're no longer selling us queues and databases. They're selling business applications. But unlike kind of generation 1 software as a service where you can't really program it that much, this is under your control, but you get this kind of business front end. Another thing that Amazon released relatively recently is this whole quick site, which is like analytics visualizations on steroids. You can do all sorts of crazy stuff with it. It's utilization priced, as in you don't have to care about how many clusters you need to do EMR or kind of reducing data or collecting data. It basically runs from almost any data source that you have in Amazon, has these nice visualizations. Couple of kind of business users I was working with kind of love this kind of stuff. You can do all sorts of stuff here easily, but you don't have to integrate another visualization package like Tableau or something like it. It kind of directly competes with that. So Amazon is, again, that was usually seen as lower in the stack. They're now starting to compete with application kind of level packages, which is really, really scary for anybody who was offering an application level thing on Amazon up until a year ago. There were lots of people going into reInvent in November thinking that they're Amazon partners, going out of the conference understanding they're now competitors. But at the same time, if you're a user of this stuff, then it's brilliant because you get to pay for it per request. The infrastructure is managed for you. And kind of another thing that is happening here is not only are these things programmable, not only can you kind of interface with them in lots of interesting ways, get data in, get data out, and things like that, and kind of pay it per request, you can also kind of mash them up to create a higher level app of your own. So a couple of months ago, 2 colleagues and I basically over a weekend built a error monitoring app for us that gives us kind of all the same benefits we were getting from Sentry. So Sentry is a company that I don't know how many employees they have. They've been building something for years and years and years. We built it, of course, not 100% of what they do, but we built enough of that service for us over a weekend by kind of mashing up different components. So Sentry collects events from your app running on the client, captures exceptions, submits those exceptions somewhere where you can search, log them, and alert on them, so you know if something unexpected is happening in your app. We kind of built the same thing, just connecting different Amazon services. We called it désolé, it's kind of French for sorry, but so effectively, what we did is we just reused their API gateway to pump events into a function, and this would then distribute it to multiple different loggers. So we had a metrics publisher for CloudWatch. CloudWatch is Amazon's dashboarding solution where you can set up flexible alerts. Something like, if more than 5% rise over 10 minutes over this thing, send me an email, page somebody, run something. So we're getting alerts. We are getting kind of with saving to their file system. We get the whole this kind of query service that we can search and investigate. We get, by reusing Pinpoint that I mentioned earlier, we can send people email that have a problem. We can automate contacting people that have a certain issue. We can mine that data. We can visualize it in dashboards. And we've also kind of connected it to Elasticsearch and things like that so that we can investigate these things. So this is, again, really, really starting to be interesting because all of this stuff is priced per request, which means if nobody's using your app, you don't pay for it. If you start getting popular, you start paying for it. And all of this is again, still ridiculously cheap at this level because it's utility priced. So we can now start replacing services like that are kind of reasonably cheap to get started, but get very, very steep for production usage with something that is just wired up together. So what we started doing for this is actually our software is more becoming a glue between different services than actually kind of the business functionality over it. Because all these front ends like event dashboards, customer engagement, API gateways, they're all there in the cloud. So this is why I think kind of we can start. Even the next level of this stuff is where you start getting an app store for these things. What Amazon launched relatively recently is this thing called the Serverless Application Repository, where people are kind of publishing their own components like this. And then you can kind of pull them into your app and wire them up. You can, compose more and more of them. And we're getting into this thing where it's going to be relatively easy to start composing even higher levels of services on top of it. Just a few months ago, they've enabled nested apps, which means you can create one app that nests different components, which is going into the same direction like Zapier and if this, then that, but it's all on Amazon. It's all composed out of the services that you control. You control the data. The reason why we built Désolé was GDPR. Because we could not trust all this kind of error information that can contain who knows what to a third party anymore. I wanted to have all the data under my control. So with things like Google Analytics or Sentry or things like that, you really need to make sure that you trust too many people about that. Where with this kind of stuff, first of all, the data is under your control. You can do all sorts of stuff around retention, optimization, but not just that. You can start building events that hook onto those things happening. So, this whole error monitoring thing can be just one part of the whole chain of things that need to happen in a wider application. So, what's going to be really, really interesting, I think, for people that do apps is when somebody figures out a way how to bill for these things. I can almost imagine like an app store where, this thing turns into, install this component, pay 0.0000 per request, and it kind of, Amazon and Microsoft and Google are going to start becoming marketplaces for business-level components, not just infrastructure-level components. I think they have all the stuff already. I mean, you can get, it's already an infrastructure marketplace, but now I think it's going to start becoming a business-level marketplace as well. So this is where there's a couple of really interesting things in this space that is different from what we had before. And I think first thing is, with Zapier, with if this, then that, the kind of infrastructure is all disparate. Some of it is yours, some of it is somewhere else, some of it is coming from one to another. You're using all these different applications that who knows, how long they're going to stay alive and where the data is, where with this you can centralize the infrastructure on a single cloud, in a single region, or distribute it, depending on your business needs. The other thing that's really, really interesting here is that we are getting utilization level pricing on this, which means it's really easy to get started, which means it's trivially easy to set up another test environment. I don't know how many times I worked with a company where, we have this all brilliant production infrastructure, but we can't really test in it because, that's important data. But the test environment, we don't have a test version of this service or a test version of that service. We don't have a test contract with these guys. So with something like this, because it's utilization-based, it doesn't really matter how many test environments you set up. Every developer can have their own complete environment. It's paid per request. And the fact that you can get all of this in a single cloud means it's all kind of consistent, which also means that it's very easy to do business experiments. With business components, we can start doing business experiments. If it's paid per request, it doesn't really matter if you send 500,000 users to a single version of your app, or to 2 versions of your app, or to 5,000 versions of your app. It becomes relatively easy to control these things. The next thing that kind of is different, I think, from Zapier and if this then that is we're getting not just kind of programmable links between components, we're getting programmable business components. I can change the behavior of these things in lots of ways. And lastly, kind of we're getting the return of outside-in integration that I think is one of the most interesting things about this. So in terms of outside-in integration, I don't have a good buzzword for it, but let me explain what I mean by that. So there's, I think, looking back at my work at least, I think there's been like at least 4 ages of software integration. So the first was universal software. Like universal software is where you'd get really, really good sales guys to convince a large company that this software does everything they need, it just needs to be configured. So then what happens is you get like 200 people in suits coming in to configure it in Java for about 3 years. And they kind of modify the vendor software, but the vendor software still runs in your environment. And this is where you get these, SAP specialists or, there's a product I always like to laugh about. We worked on it together. Some people call it Collapso, some people call it Apocalypso. It's a kind of fund management software where it's sold like this. Basically, it does everything, you just need to configure it. And you configure it for a few years until you give up, basically, and that's it. So most of that integration is inside out. What I mean by that is you get these specialists that really know how the product works from within, and then they call into your things, they modify the workflows, it's in queues, which makes it really, really easy to customize the stuff. This is why it can do everything. Now, when kind of the cloud started emerging, people are no longer running their infrastructure anymore, and this is kind of was difficult to do this kind of, we'll come and we'll sell you 300 people to install it for 2 years. That it was no longer a viable proposition. And with the kind of first generation of this stuff, we were getting software that, the vendor is running its own stuff, but kind of we are just iterating with them and we're using the APIs. This is Google Analytics, this is a lot of the Salesforce stuff, and still today, this is a very popular way of integrating the stuff. And the problem with that is it's kind of outside in. You are trying to talk to an API that, somebody decided what it works, and the more popular the API becomes, the more use cases it needs to cover. Which means it needs to become more and more generic, it needs to grow more and more, it needs to kind of satisfy more and more use cases, and at some point, these things kind of fall over because they're no longer sustainable. And we get to kind of a situation where pretty much at some point somebody says, just fuck it, here's all the data. And we get these kind of SQL-like APIs that are no longer satisfying any particular use case, just kind of, people start integrating this. In the cloud, of course, SQL is a kind of bad word, so we get GraphQL instead of SQL. And you can see more and more of these things actually happening. GitHub is a nice example. Last year, they basically gave up on version 2 of their API. They said, just kind of, here's all the data. And the big problem with that is it's really, really difficult to create a unified interface for all the possible use cases of a successful business. And the more generic an interface like that is, the more you have to suffer trying to use it. I hate GraphQL. I want a nice little method that just does what I need. I don't want an overly generic thing to kind of fight against, but I can understand why the service providers are going for this as well. So the kind of other type of integrating inside out is much, much more flexible, because when you're integrating inside out, a provider can say, okay, for you, we're going to create a special case. I don't care about anybody else. We'll keep it running for you, or we'll create these 10 different use cases. It doesn't have to be overly generic. They can do a lot of backwards compatibility. They can do a lot of other things like that. And generally, kind of, in the age of web, we were really suffering with inside-out integrations, because then a provider needs to talk to you, not the other way around. So the first kind of experiment with this are kind of webhooks. And that was the next stage of integration. And where basically, I'm going to run my own software, the vendor runs their own software, and the vendor can talk to me using HTTP, because HTTP is brilliant for everything, of course. Unfortunately, it's not. There's kind of, no transactions. There's very little control over it. And HTTP wasn't really designed to be an application protocol. It's a document protocol. So the problem kind of here is that it's all based on document stuff rather than application stuff. Yes, you can do RPC over HTTP, but it's not that nice. And if you want to do document stuff, you can create something that's incredibly customizable. And Slack, I think, is a big testament to that, because Slack, in effect, is a $7 billion webhook system. Their entire business is letting people do webhooks so they can enrich their product and managing those webhooks effectively. So if you're doing something document-based, that's amazing, like rendering information. But if you want to do something that's kind of controlling an app, webhooks are not really that good. So I think kind of, my universal laws of webhooks is that they're always going to be messy. And they're going to be messy because HTTP is not a good application level protocol. So first of all, if you're doing something connecting to Slack and they need to connect to you, they have a lot more capacity than you do. So lots of people have been experiencing effectively denial of service, where you have lots of requests coming and you don't have a pipe big enough because somebody starts bombarding with information. So that's a problem. The other problem is, generally with HTTP, timeouts are an issue. So if they send you a message, you don't respond quickly enough. Is it because you're still processing it? Is it because it's dead? Is it because there was a problem in between? Is it because the routing's down? It's all built for a happy day scenario, the whole webhook system. Any error cases are really difficult to handle there. Then you have to do this whole problem of, should they retry or not when there's an error? When do they retry? Do they retry all the errors? Do they retry errors that are kind of, how do you tell them it's a recoverable error? Where, and all of these things are really problematic. Transactional state is another big issue here, because you're crossing so many boundaries. You might finish part of the work, they retry, you start running it again. So it's complicated, it's just messy to program this stuff. Every time we had to do a webhook to receive payments from Stripe or PayPal or something like that, most of the code is not receiving the payment. Most of the code is all the crap around dealing with the webhook. All the stuff around, is this a replayed message? Is it not? Am I already doing it in a different thread? So all this other stuff you need to do, there's just kind of webhooks are messy. And kind of, lastly, monitoring with webhooks is kind of a big issue, because you need to go to Stripe to see have they sent you a message. You need to go to your system to see if you've received it. It's all over the place. It's just a mess. Now, authentication is kind of the last big problem there, because we rely on kind of shared secrets. So I've given Stripe, some key, and they send me that key, and if I get a message with that key, I kind of trust it's Stripe. Well, that's okay if I'm receiving, I don't know, a couple of $1,000s a month, but if we're doing something that's a lot more valuable, is this really the level of trust we want? Or, we have all these cloud providers now that have much, much, much better authentication systems, identity systems. We're still relying on stupid shared secrets for webhooks. And this is where I think this other kind of part of business components and deployment as a service is interesting, because when everything is deployed on the cloud provider, a lot of that stuff does not necessarily need to hurt. For example, Cognito, that's another kind of Amazon service I think really fits into this space. Cognito is their end user management service. Cognito is a managed username and password database where Amazon does two-factor authentication, does all sorts of security things, does user properties, does all sorts of other things, and you can program it and you can use it as a user database. And it costs, I can pull out the pricing, but I think it's something like $5 for 1 million users a month or something like that. So it's not really going to kill you from a budget perspective. But Cognito is programmable from inside out. You can put hooks in it to say, well, before somebody signs up, call this thing. I'm going to integrate into the workflow, authenticate it, prevent it, explode. So if you want to do blacklists, if you want to do all sorts of really interesting things with the sign-up workflows or before authentication, after authentication, you can plug all these things in, but you don't do it with webhooks. That's interesting, because webhooks are messy, and for something like this, you really don't want to be kind of dealing with webhooks. You do it with, on Amazon, Lambda functions, or on Microsoft, that would be Azure functions, or on Google, it would be Google Cloud functions. Those are kind of webhooks for the modern age. They are executable pieces of code that don't suffer from this whole HTTP craft around it. Because when, I think what we started realizing is this whole promise of, only 4 computers in the world, that's, an overly used joke now that, yes, there will be 4 computers, but kind of, Amazon Cloud, Google Cloud, and Microsoft Cloud. When you have such a centralization and kind of you are running your software there, the applications you want to use are running their software there, everything is there, do we really need to use HTTP to communicate from Amazon to Amazon? Why? So it's all there anyway. So what we're getting now is, with this new age of services, we're getting application-level components, business-level components that you can plug certain things into to integrate inside out. That's a lot more flexible, a lot easier. They can do a lot of different things for that. You don't have to have an overly generalized API, but you control the integration. You don't have to pay 200 specialists to do it. So this is where kind of another really nice example of that is Lambda at Edge, which is basically they've allowed people to run code in the CDN. So when a request comes to the CDNs were traditionally stupid in a sense, okay, they're going to call into the backend, cache things, but you can now run code in the request pipeline of the CDN. And you can customize that inside out. You can do lots of really interesting things with it. And other providers are started to get into kind of this mode as well. We are getting this kind of almost software as a service glue around this, where you modify the vendor product, but you do the work, not the vendor. But we're getting back to kind of inside-out integration, much, much, much cleaner than webhook. And the interesting thing here is, because the provider is running the whole infrastructure, they can make all sorts of assumptions about when do we retry, when do we not retry, what do I parallelize, how much load can I give, and all those sorts of stuff that kind of is messy with webhooks goes away. That's kind of really, really interesting here, because that's a lot less code you need to write, and a lot less code I need to write. So there's a kind of bunch of these memes that were always coming up with, in Soviet Russia, this and that. And I think kind of, when we start thinking about the cloud today, it's really kind of in the cloud, you no longer program the API programs you, effectively. Or kind of, we're getting into this mode where we're getting more and more of these business components where they're going to kind of call into our application and program our application rather than the other way around, which I think is really, really powerful from lots of different perspectives, because then you can focus on writing only the kind of tiny bit of business level code that's unique for you, rather than doing a lot of this whole infrastructure around it. And for me, as somebody who's kind of building a product on his own, with kind of, again, a lot of other things I need to do, writing less code, maintaining less code, and reusing all these things is really, really critical. So Twilio is one of the exhibitors there, and Twilio recently kind of started doing their own thing like this, where, up until a year ago, Twilio would call onto you using a webhook or something like that, and all the mess that comes with it. But Twilio started offering functions relatively recently. Functions as in, give us your code, we're going to run it. And then you don't have to worry about retries, you don't have to worry about transactions, you don't have to worry about monitor, or kind of monitoring is all in the same place. You don't have to worry about all these other things. And that's kind of, I think, an interesting extension of this, where if everything is on Amazon, you can make all sorts of nice assumptions, because Twilio is on Amazon as well. And if you look at their interface for functions, this is literally the interface for Amazon Lambda functions. So what they're effectively doing is they're letting people run Lambda functions that they pay for, and they probably just charge a tiny bit of money extra on top of it. So instead of hosting your own service that kind of talks to Twilio, you just kind of can let them run it and pay a bit more, utilization pricing. They make money, Amazon makes money, everybody's happy, but you write 5 lines of code. Another provider that is doing something very similar is Netlify. Netlify is a web hosting for kind of millennials. That's a new generation web hosting service where you get all sorts of stuff integrated nicely. And again, with Netlify, you need to customize the app at some point for something. And what they used to do is let people call into an external service for some stuff, but because they're on Amazon, you're on, or, if the application is Amazon and they're on Amazon, again, they can offer functions. And if you look at the function interface that they're offering is the same as an Amazon Lambda function. So effectively, they're doing the same thing. They're reselling Amazon's code execution. And my assumption is that going forward over the next 2 or 3 years, we're going to be seeing more and more application providers, more and more service providers doing the same thing on all different clouds. So instead of hosting your part of the app on Azure and then talking to a service provider that's also hosted on Azure using HTTP, and they talk to you using webhooks, and everybody has to suffer through this mess, just go one level deeper and run it using Azure functions. And that's kind of what I think is going to be happening more and more and more. So kind of, I want to show you a bit of code that I've done and how this whole thing wires up together to create an app effectively. So in the app I'm building, I've reused Cognito that I've mentioned. I'm using it as a username and a password database because I trust that Amazon has people who can do programming for security much better than I can do. So, I can just use their stuff. I host usernames and passwords there, and that gives me out-of-the-box two-factor authentication, gives me out-of-the-box user preferences, gives me out-of-the-box synchronizing user data on all the different devices. Kind of, that's at least a month of my work if I want to do it on my own properly. I'm also using kind of Amazon Pinpoint there to do analytics, to have all sorts of events when they come in, both from the front end and from Cognito and from all this stuff to get dashboards. That's another kind of month of my work, at least. Plus, I'll never build it as good enough as they are and scale it. I'm also using their step functions. Step functions are a really interesting service for business workflows, where you can design a workflow and you can say something like, whenever a new user registers, send them a welcome email now, a week later, go here and check if they have this event. Like, have they actually completed the sign-up? If not, send them another email. A month later, see, are they using the app? If they are, send them tutorials. If they're not, send them getting started guides. So you can kind of design the whole workflow. The workflow can run for up to a year. And it can call into all sorts of other stuff. Again, programmable business level components. So just, usually, I don't know how many companies I worked with where this whole onboarding workflow takes a long time to, design, agree, change, test, retest, and things like that. You get that almost out of the box. You just need to describe the workflow. It can call into lots of different things. So kind of the app I'm building now is this thing here where it allows people to create videos from scripts and screenshots and things like that easier. It's kind of version-controlled, CI-built videos for your documentation, because I need to build videos and I can't fiddle with the mouse and align things myself. I built a synchronization thing. So the app itself is not that important for this, but kind of these two buttons are. These two buttons don't lead to my software anymore. These two buttons lead to software provided by Amazon. When I use Cognito as a username in a password database, I automatically get a sign-up screen and a sign-in screen managed by them that I can configure. So the URL is no longer kind of the main application site, it's the authentication URL. And I get to kind of sign up here. So, all this kind of stuff that people end up with kind of interface, is my password correct, incorrect, that's all provided by them. You can just configure what the password rules are. Again, I can activate two-factor authentication. I can activate lots of different things. It's out of the box. I can activate signing in with Google, Microsoft, all these kind of weird things that people spend weeks doing when they start the project. It's there. And kind of when I sign up now, they're going to kind of verify the email. I get a verification code now that I can type in. Let me see. So this is still kind of their software. Come on. Okay, I'm going to be a bit cheeky and turn this off for a second until I check a verification code. Come on. Okay, so I get let me put this back on. So I got an email from them, basically from an email address I control saying, your verification code is this. Now I kind of go and type this back. I get my account confirmed. Now, what's kind of interesting is now I can, sign in and things like that, but I got, I should have received now another email, or should kind of come relatively soon. Yeah, I got another email that's basically welcoming me now and saying, here's all the stuff. So this is all done by the onboarding workflow. The onboarding workflow is kind of configured. So the onboarding workflow is configured to register. Let me see if I can zoom this in a bit more. So the onboarding workflow is configured to register a user, send a welcome email, then send me a notification that somebody registered. I can do lots of really crazy stuff here just by configuring it. Of course, as a developer, you don't use this. This is a visualization thing. You use version-controlled ways of configuring the workflow. I get automatically stuff propagated to the analytics console where I can look at my demographics, I can look at the usage, I can look at all sorts of kind of stuff. I can create segments. I can now create marketing campaigns based on this stuff. I get a user managed through my user pools where I have all sorts of, security features there. And that's all just wiring these components together, which is, for me, absolutely amazing as what we can do now. So we're moving far beyond the kind of using software as a service to being able to kind of program software as a service and compose our own applications of that. So I don't need to manage, I don't need to worry about the standard stuff for a username and a password. That's done. I don't need to worry about the standard stuff around creating analytics and logging events and kind of processing that. That's done for me. What I need to worry about is 10 lines of business code that is not standard for them, that's kind of specific for my business. And that's what becomes really, really interesting. And with this whole, don't use webhooks anymore, use functions, I don't have to worry about all the craft around kind of executing over HTTP. And that's, for me, this is absolutely phenomenal. So the big problem, of course, and the big risk that anybody serious is going to start thinking about at this point is deprecation. Because if my app is no longer 90% my app, it's 90% wiring all these different services, and it's 10% my app, yes, I can develop it 10 times faster, but what happens if they deprecate services? So that's a serious big risk. And that's what I think we either need to start developing things that can run on multiple cloud providers with multiple options, or we need to kind of choose the right partner there, where that's really something that each company is going to have to figure out on their own. I kind of started looking at some statistics for this to figure out, is there anything public? The last statistic I found was from 2013, so not the most recent one. But from 2013, they have a ranking table where kind of Google killed 30% of their APIs almost. And kind of, Amazon killed 11% of their APIs. Microsoft kind of killed 13% of their APIs up until that point. I burnt my fingers with Google more than once, so I'm kind of really reluctant to trust them to keep things running over a period of a couple of years. But my experience with Amazon and my understanding of other people's experience with Microsoft is they're reasonably good operating these services over a long period of time, which is another benefit of having everything in the cloud provider. You don't have to trust 20 different companies to run your business components. You trust one provider well. So again, that's a risk. That's a risk that people have to kind of think about and deal with. And I think at the end of the day, the decision comes to kind of what you want to optimize. Because I think when you have the deployments in the cloud, you can choose control, or you can choose massive scale and productivity, but not all at the same time. The fact that I can use Cognito and Pinpoint and the step function and things like that, those things are built for massive million-user workflows already out of the box. So I can spend my time, building my own service there, or I can reuse that. And it's I guess, the question between these three things. So for me, I kind of chose productivity and scale over control. You might want to choose a different thing. So kind of to start wrapping things up, I think we're getting into a really exciting period where all these kind of code execution services that started appearing a few years ago, they're now getting used in higher and higher levels of abstraction. And more cloud providers are reusing those things for integration. Not even cloud providers, service providers like Twilio or Netlify, they're using these things for integration, which is going to allow us to delete a whole lot of code. And kind of, if you are building a product on the cloud, I would strongly suggest do a bit of research, because these things are popping up like crazy. Most of the stuff I've mentioned wasn't really available a year ago. I had luck to start building this up a couple of months ago and use that stuff. So I think we're going to see more and more of these things emerging. So if you are building a new app, if you're kind of starting out, have a look whether kind of the stuff you're planning to build is already 90% available there. If it is, just plug the remaining 10%. At the same time, for people that are service providers in the cloud, if you're using webhooks to let your clients talk to you, please kind of use your kind of use the functions of the cloud. It's going to be a lot easier for you. You will be able to manage it a lot easier, and generally people will enjoy programming that interface a lot more than stupid webhooks. So that's kind of pretty much it. I'll leave you with a couple of links. If you want to look at the code for the error monitoring thing, we published it on GitHub. You can look at it on Désolé.io. Serverless.pub is a website that I contribute to with writing, and I wrote a bunch of things. I'm cleaning it up. I'm going to publish the whole shell for everything I showed you. I just need to pull it out of my app and publish it. I'm going to publish it on that website in the next couple of days. So you can just download and run that. The third thing is my website where kind of I blog, and most of the images I stole from unsplash.com with permission. So that's pretty much it. I hope I've kind of tickled your imagination at least a bit. Thank you very much. We have a couple of minutes for questions if anybody has any questions.
So the inside-out programming, as you call it, I think the example was JavaScript or Node.js. Do you have options there on your?
All of these function execution systems support multiple languages. So Amazon supports Java, Java, .NET Core, Go, JavaScript, Python, probably something else. Lots of options. Basically, you have this interface where you get an event, but because it's running in their execution environment, they can do lots of interesting optimizations, lots of interesting assumptions about what they do with errors and things like that. I think the big problem with webhooks for me is webhooks are designed for a happy day scenario. Like running a service on something that is designed for a happy day scenario is really problematic. You have to do a whole lot of code around it where with these things, they can actually make quite good assumptions about should they retry, should they not retry, should they send it to somewhere else. For example, again, I assume you can do this on Microsoft and Google clouds as well. I don't know that much, but with Amazon, you can create things like, if this function fails 3 times with the same message, send it somewhere else. So you can then have a backup, you can have, or you can log it, or there's lots of things you can do with it, or you can kick off a workflow. So it's much more robust. But yeah, you can usually do it in lots of different languages. Okay, we have another question over there.
What's the development story? How do you develop anything when you're only
Usually in Vim. So I kind of, the nice thing about Amazon, again, I'm really out of my depth when I talk about kind of other clouds. The nice thing about Amazon, I think, compared to what I've seen on Microsoft's cloud is with Amazon, you can actually describe the whole infrastructure as a JSON file and have it version controlled. So the whole configuration is version controlled. That's why I can publish it on GitHub. So all of this stuff is in text files that get deployed, and you have an atomic deployment that succeeds or fails with CloudFormation. I assume other cloud providers have already caught up or will catch up to something like that very soon. So basically, you describe a so I don't know, analytics. So this is my analytics stack. I can create a bucket for storing analytics events. I have this security role that you can ignore. Then I have a function that is when an analytics event comes in, just copy it into kind of the bucket. But then I also have, from analytics to pinpoint, I also have from analytics to send me an email for any user feedback. And log task analytics, kind of put them into, log all user requests to kind of something else. So you describe the whole infrastructure like that with queues, with all of these things, but not just queues. You can kind of wire all these business level components as well with that. And that's what I think is interesting. And then kind of, your code gets deployed as part of this in the CI pipeline. Does that answer your question, or have I kind of gone completely in a different direction?
Yeah, so every developer spins up their own version of the code environment?
Potentially. Yeah, it doesn't cost you almost anything because everything is priced per request. So every developer can spin up a copy of a prod environment because it's version controlled. You can propagate different things. Some companies do it one per team. Some companies do it one per developer. That really depends on how you want to organize your development. But yeah, in effect, every developer could have their own copy of Google Analytics and messaging and CRM and everything if you want it like that. And it would cost you exactly the same as all developers working on one because it's mostly priced per request. Okay, thank you very much.